Welcome back to Jamieson's Repair Shop. Just you and I in the shop here today. It's quiet. Heater's not on. No cars roaring by. It's raining outside / snowing. It's kind of a mix of rain and snow. It's the first day of spring here in Saskatchewan. Looking forward to the summer. But what I want to do today is cover a topic that was brought up by John from Arkansas. He had a request. He wanted to know how I do my plug welding, or joining like this, spot welding, plug welding. Plug welding would be if you have a hole and you're bonding it to another. Spot welding would be electrical resistance through the two pieces, bonding them together. But we're doing plug welding. I do have a spot welder, but I use mostly the Mig Welder for doing my plug welding. So let's get into this, and I'll get us set up over by the welding table. So grab your chair and we'll go over there, and I'll punch a few holes with my hole punch, and I'll explain what I'm doing. So let's get on with it. First step, so we got this piece primed, and I'm going to leave it primed. And this side here needs to be deburred a little bit. So I'll get my air tool out, and we'll do a little deburring. I got the metal deburred. Like I said, I'm not going to take the primer off this, but I am going to put some holes in now. Okay, so I got the hole punch. So this tool does flanging and punching. So I'll put a few holes in, make sure it's in deep, give it a click. Just do a few around because we'll do a couple of these welds. Hopefully you can all see that. There we go. All right, so now that we have some holes put in, I'm going to prime the back. We'll just pretend I primed the back. We don't really need to do it, but I would have it primed. Now I went ahead and I punched it out with my hole punch tool, hole punch flanging tool. The only thing I find with this hole punch tool, it's a 5.5 millimeter punch. So that's what comes out of here. I find them a little small for my welding skills. But they work, and we'll do both. But what I like is like 5.5 millimeter is around 1/4 inch or so. Excuse me. I'm not 100% sure what the conversion is. But anyway, this is the size of hole, but what I like is 5/16. I prefer a 5/16 hole. So what I generally do, I'll take a 1/8 bit and drill it out. I'll start it with a 1/8 bit, and then I'll take my stepper. These are great for doing this sheet metal work. So you can see it there. This stepper here is 5/16 is on the 3rd step. So 1, 2, 3. So I would go to the 3rd step and just make it a little larger. I use the 1/8 just to get it started. It's a little easier. So, and then you can flip it over and deburr it with the same tool, like that. Good. With the punch, the hole punch, this tool here, you don't have to deburr. It does a nice clean cut. So anyway, so there's the difference between a 5/16 and the hole punch. So my recommendation, if you're buying one of these hole punches, and this is where I made a mistake, I bought it before I was using it for anything, and I bought one that was I feel too small. I would go with a larger one. 5/16 if you can get it. 3/8 might be a little too big, but anyway, so here we are. So we have some metal ready, and I'm pretending I primed that already. This is already primed. So let me get a clamp, and we'll clamp this down, then I'll show the next step. Okay, I got some holes drilled, and having multiple drills is really quite handy. So the 1/8 bit, stepper bit, and now what I do to clean up the primer that's in there, I have a bit that I just flattened off, put on the bench grinder, and I just squared it off. and it does a pretty good job of cleaning up the primer. So let me just zoom in on this and we'll see how it looks. All right, so now I have my squared off bit. It's probably going to be fuzzy. And all I do is just go around like this. Clean out those holes. Now, with these, the squared off bit's a little bit larger than the punched hole, so it does hog them out a little bit. But you'll want to get all that primer out of there. So now I'm going to grab a blowgun and I'm just going to blow the old metal filings out. And I can see the primer's not all out there. There we go. Done. Alright, so give me a second. Alright, so now we have the holes drilled, a couple different sizes, 1/4 inch up to 5/16. And now we have the primer cleaned out. Remember, I primed both sides in imagination, but that's what I would normally do. Now I'm going to set up the MIG welder and I'll tell you how I do the MIG welding. Alright, so this is my MIG welder, and you've seen this in other videos. It's not a big welder. It does work really well for sheet metal, but it does have its limitations on thicker metals. So when you're welding like half or 3/8 or anything like that, you really have to turn it up and give yourself a good place to do a root pass. But anyway, let's get back to sheet metal. I don't do much of the heavy metal. So on sheet metal, on this particular welder, I set it on the second setting. I find the low setting for 18 gauge, and that's what this is. I should have mentioned that. I use 18 gauge pretty much for everything. The odd time it goes different either way. But on 18 gauge, I set this MIG pack on 10, or 10 rather. This MIG pack on setting B, and which that is kind of a downfall on these. There's no variable, it's just a set selector, which if you're buying a new welder, I would recommend to get one that you can actually have variable adjustments on the voltage end of it. So the wire feed right here, I run it just under 6. But that's just for doing butt welds. To do the plug welding, I generally crank it up one more notch, and then I turn up the wire to around 8. Now you're only pulsing this because now you're running pretty hot even for 18 gauge. It's sitting on the welding table, so it's not going to burn through. But if it's on a car, you could potentially burn right through because of the heat and the wire feed. So that's what I do with my settings for the plug welding. And my shielding gas it's by Air Liquide, and it's a Blue Shield 8, and that's an argon CO mix, carbon dioxide mix, argon and carbon dioxide. And I believe, now I could be wrong on this, but I believe it's 75-25, the mix. So 75 argon, 25 carbon dioxide. So on my flow for my shielding gas, I run just under 20 on this gauge here, and that's cubic feet per minute. So that's my gas settings. So my welding helmet, and I just cleaned it with some alcohol mix here. This is it's a Yes Welder, sorry, if you can see all that. Yes Welder 2.0, I believe it is. It's a true color, and it has a whole bunch of settings on it. I like them. They're great for hobby kind of thing. I don't know how well they would hold up in an industrial situation. They might be a little light for that. Don't know. But I also added this light on after watching Outlaw Edge, and Arco had done the upgrade on his. It really made a big difference for this with my welding, is being able to see what I'm doing. So that's my helmet, and then I added on just a rechargeable LED light, and I just glued it on with some Gorilla tape, double-sided Gorilla tape, the clear stuff. Works good, hasn't fallen off yet. And then I can just, if I want to charge it, I just pull it off, take it over to my charging station, and there it is. So that's the welding helmet. All right, I hope you can see this. I'm going to try to get in as close as I can. So I usually have a roughly, oh, there we are. roughly that much wire sticking out. Now you'll notice that that end has got a ball on it. Now I don't always do this, but it is recommended, but I'm not that diligent with it. So my recommendation doesn't mean much because I'm not doing it myself. But what you want to do, you want to do it somewhat right. Clip that off, set of side cutters, and then you start with a fresh point. That little ball, it causes a little more resistance because it's a buildup of metal there. On this kind of work here, it's not that critical, but in other places it could be. But again, I'm not diligent with that, so take for what it's worth. All right, so we got that. We have that much wire sticking out, and let me zoom in and I'll show you how I start welding it. Now I got you zoomed in pretty good, and I have my my glasses on. My welding glasses is at a distance. It's hard to tell what's going on, but I can see through the camera. So this is kind of what I do. I try to get the edge here. Now I used to go in here like this and do it, but I found I had a lot of welds that you couldn't say they were good, and I would go around and build it up. And it's okay if you have a clear place to work, but I found that sometimes you're in a tight spot and you're not really getting in deep and getting a nice hot puddle in there. So what I do is I hit it there basically like a stitch weld, and I just go around. And then you can do the same with the smaller holes. That's why I like the bigger holes. It gives you a little more room to work, but it can still be done. So if you catch it right there and give it a shot, it seems to work really well. Again, this is how I do it. If you're using flux core, I really don't know how that's going to work for you because you'll get a little bit of slag every time. So you may have to stop. You do a weld and stop and clean it out, but that's something you'll have to experiment if you're using flux core. So let's get started. I got my helmet on. I'll turn on the welder. And she's set at the higher settings than I normally would do a butt weld. My helmet down. You might not hear me. Put my helmet down. Got the light on. Let's do a shot. All right, so that gives a lot of wire right off the get-go, but there's good bond between you probably can't see it as well as I can, but there's a good bond between the two plates. So let's continue on. All right, now, see what's going on there? Someone forgot to turn the gas off. So there you go. So now, if you want to know what a bad weld looks like because no gas, well, there you go, right there. So I'll trim the wire again. Let's go after the smaller holes. So yeah, I made a mistake. No gas. And that's what you'll look like. You'll know right away. All right, let's go after the other ones. There you go. That's all one that goes pretty quick. I found it a little awkward because I'm trying not to block your guys' vision. So let's see if we've got any penetration on the other side. Let's pull it off and have a look. Oh, there we go. So you can see that the heat has come through. But like I said earlier, when I was running it at the same temperatures that I was running for butt jointing, for the butt joint welds, it wasn't hot enough. But now it comes through nice. Whoop, there we are. And then you got to see me make a mistake with the no gas. So if you're getting welds like that, your gas is turned off or you're out of gas. They should look much cleaner like these other ones. Missed a little spot there. You can always, once you grind it off, you can see the spots you missed. But that is on there solid. That's not going to pop off. See? Oh, there we are. This one here isn't great. Well, the one that I made the mistake on, that's not a good weld, so it's not going to be strong. But the other ones are good and strong. Yeah, they're not even budging. Well, there it is. My demonstration on how I do plug welds. I find I've had good success with this method. I think Tony on Fitzy's Fabrication does it similar to me. Like same, he goes around the perimeter of the hole. But they all work as long as you can get the heat in and get that, as long as you get the penetration. If you're not getting the penetration, then your plug welds aren't going to be very good. They won't be strong. It takes a bit of practice, and I'm still practicing, believe me, I'm not an expert on this. And John, I hope you found this helpful. I know it's different than what you use. You're using the the flux core, but I think you'll make it work with those very similar ideas getting in. The only difference is with the flux core, it does leave that slag in there. So I don't know if you'll have to clean it out every time to restart if you want a good weld. That's something that someone may be able to chime in on that does use flux core. I believe Troy does use flux core because he works mainly outside in Arizona, which I wish I could do that. The only drawback is with outdoor working, the shielding gas doesn't work as well, especially if it's not in a sheltered area where it's a cross breeze. Shielding gas will be blown away on you. It's an important part though. I mean, you're building these cars, doing these things. If your welds aren't strong, I mean, that's what's holding the car together, especially on structural stuff. So it really need that penetration, like I said. So if you're not getting this, and this could even be more, like you could actually get bulges on this side, would be even better. But I feel it's strong. You can see the distortion in the metal right in the core of it. So I know it's bonded in well with it. Anyway, I'm just kind of rambling on here now. I really appreciate everyone that's watching this video. I appreciate the subscribers I have. If you're watching this video and you're not a subscriber, hit the subscribe button and check out my channel. I got lots of Thunderbird stuff on the go, and every now and then I'll throw out something new. It'll be coming up on soon with this Thunderbird. There'll be some mechanical stuff as well. There's a lot of parts that need to be rebuilt, so lots to look forward to. All right, well, thanks a lot for coming to Jamieson's Repair Shop today, and we'll see you in the next one.